So students, this is your very important equation for n-slit diffraction pattern, of which this corresponds to the interference term. Okay, so which we start off. Let us include this factor. Let us represent this factor sine square n beta by sine square beta as z. Sine square n beta by sine square beta as z. Then let us find out the value of dz d beta. Okay, and if we equate this to 0, if we put this as equal to 0, the first differential coefficient of z, then the intensities of maxima and minima can be obtained. Okay, so if we put dz d beta equal to 0, what is dz d beta? Well, dz d beta, if you do, it is, well, you keep the first term constant, you integrate the second term, differentiate the second term. So it is like this. You get it as sine square beta into twice n sine of n beta cos of n beta, isn't it? Minus 2 sine square n beta sine beta cos beta, isn't it? Sine beta cos beta, okay, divided by sine to the power 4 beta. Okay, all right. So this, if you carry on, this is equal to, if you just proceed, all right, this is equal to, you can show this as equal to twice n sine of n beta cos of n beta minus 2 sine square n beta 1 by sine square beta cos beta by sine beta. This is equal to, okay, twice n sine square n beta cos of n beta divided by sine square beta sine of n beta minus 2 sine square n beta divided by sine square beta into cos beta by sine beta. Now this, actually you will get this in your books also, all right, because they have done in your books. So please proceed with this calculation yourself. 2 sine squared, so this is what you get as your ultimate expression. You're arriving at the ultimate expression by sine square beta into n cot n beta minus cot beta. So see, you have arrived almost at the expression. So this is actually equal to 0 as your condition for maxima and minima, which means either this is equal to 0 or this is equal to 0. Now the condition for principal maxima, it means either this is equal to 0 or this is equal to 0. Okay, so the condition for principal maxima, if you consider the equation, well, sine of n beta by beta. Now if sine beta is equal to 0, then actually basically when sine beta is equal to 0, then beta means beta should be equal to plus minus n pi, where n is equal to 1, 2, 3. So to find the value of this limit, sine of n beta by sine beta, because sine of n beta by sine beta for sine beta equal to 0 means it's 0 by 0, isn't it? So this becomes indeterminate. So to find the value of this limit, the numerator and different denominator, if you differentiate, what do you get? Well, limit beta going to n pi. So what are we doing now? We are looking for the principal maxima. Principal maxima. Okay, so here you see, if you take limit beta equal to n pi, sine of n beta by sine of beta, what do you get? This as this you obtain if you take, to get the limits, you differentiate sine of n beta and sine of beta. So what you get over here is something like this: limit beta going to n pi, okay, d dt of sine n beta by d dt of sine beta, which is equal to limit beta going to n pi n cos n beta by cos of beta. So that if you do, it is equal to plus minus n. This is very important. This limit that you arrive at through your calculation is very important. Thus the resultant amplitude in these direction is proportional to n. So the resultant intensity I, okay, will be equal to n square. Okay, so basically is proportional from the interference term. This is actually proportional to n square. It is proportional to n square. So the intensity of principal maxima, if you just the total intensity of principal maxima, the intensity of principal maxima I, it is equal to r square, which is equal to a0 square sine square alpha by alpha square n square. Okay, so these maxima are intense and they are called principal maxima. If you remember, when I was teaching you all diffraction, I was talking about this principal maxima very often, isn't it? So these maxima are intense, they are called principal maxima. Okay, the position of the maxima, the position of the maxima will correspond to what? Will correspond to beta equal to pi by lambda a plus b sine of theta, which is equal to plus minus n lambda, isn't it? So the corresponding equation for the grating becomes a plus b sine of theta equal to plus minus n lambda, where n is equal to 0, 1, 2, dot 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 dot. It goes on like that. Okay, all right. The plus minus sign indicates that there are two principal maxima of the same order lying on the either side of the zero order maxima. Okay, all right. Next we have to find out the secondary minima. So let us do that in the last slide. All right.